This is Geometry, Unit 5, the property of kites. With the property of kites, first we'll talk about the definition of a kite. A kite is a quadrilateral with two sets of consecutive sides congruent. So that's what makes it different than a parallelogram. A parallelogram has two sets of opposite sides that are congruent. We have two sets of consecutive sides congruent. A rhombus has essentially that same property. They just happen to all be congruent, but we don't consider a rhombus a special type of kite. A kite is a totally separate category of quadrilateral. So one thing we're looking at here are perpendicular diagonals. The diagonals would be perpendicular in a kite. There's a lot of cool properties that are going on here. One of them, you can look at this triangle and you can see that it has a one ticker side, has a two ticker side, and also has the reflexive side in between. Same thing as down here. So these two triangles are congruent to each other, which are going to make several different properties true. For one thing, it makes these angles congruent. If the triangles are congruent, then the corresponding parts are congruent, so that's how we get these to be the same. You'll also see that the diagonal is going to bisect each of those angles. So if you know the one-sided angle, then you know the other side. But the diagonals will always be perpendicular to each other. So if a kite, then diagonals are perpendicular. We also have if a kite, then one set of opposite angles are congruent. So we'll come down and take a look at our first example. We're looking here, we see that it's a kite because it has one consecutive pair and another consecutive pair that are congruent. So in between the two that are not the same, these are going to be congruent to each other. So we could consider those both to be x because they're both going to be the same amount. So we have 88 plus we have the measure of angle t plus we have the measure of angle r plus we have the 70. We have all those angles, and three angles are going to add up to, or those four angles are going to add up to 360 degrees. Here we get 158 degrees. Our x plus our x is our 2x, and that still equals 360. And then it becomes an algebra problem. We divide by the 2 to figure out what x is going to be. So we figured out that the measure of angle t is going to equal the measure of angle r, which they're both 101 degrees. Okay, on this one over here, we notice that here are the two consecutive sides and here are the two consecutive sides that are congruent. So this angle is supposed to be congruent with that angle. So this is 113 also. So we have 113 plus the 37 plus another 113 plus the measure of angle W. That has to equal 360 degrees. Well, here we have 226. And then combine these together, we've got 263. So subtract that across. So it looks like we have 97 degrees is for the measurement of angle W. So 97 degrees, 113, 113, 37. So here we're looking at the side lengths. We're told that AE is 4. We're told that DE is 3. Not really drawn to scale there, but that's alright. BE is 3. And EC is apparently 7. So when we look at this, we're trying to figure out the measurements of the sides. Well, we see that this is definitely a kite. So we're dealing with this right triangle. The diagonals are perpendicular. It even shows you the square in between. So we're trying to figure out this AD length. Well, one thing we remember is that the hypotenuse squared equals the leg squared plus the leg squared. This is a right triangle. So AD squared is going to equal 3 squared plus 4 squared. So AD squared is going to equal 25. When you take the square root of both sides to get rid of the square, you're going to get AD that equals 5. It's really plus or minus 5, but when we take the square root in geometry, we can't consider negative 5 as a length in geometry, so of course it's positive. So this is 5, and a kite has consecutive sides congruent, so this is 5. It makes the same 3, 4 blank triangle. It's a Pythagorean triple. It's another way you could get through it real quick. And then this length, these of course are going to be the same if it's a kite. So CD squared is going to equal the 3 squared and the 7 squared. So CD squared is going to equal 58. And when you take the square root of both sides, we have the square root of 58. Well, 58 can be broken down into 2 times 29, but 29 can't be broken down anymore. We don't have pairs of the same number, so that's why square root of 58 is acceptable. I would prefer that over a decimal. Alright, so next you go ahead and try this one. You can pause the video, work through this one, and then come on back to it, turn it on, and I'll work it through with you. So here we have our kite. So you know you have a right triangle. So 3 and 7. So we're going to have EW squared to equal 3 squared plus 7 squared. Hopefully you've already worked through this. We get 58 again, kind of like a previous problem. So the square root of 58. That's our problem here. Alright, and for us to figure out the other length, we have a right triangle with 3 on this side and 10 on that side. So this is WT. This was EW. So WT squared is going to equal 3 squared plus 10 squared. So we have the square root of 109. The square root of 109 cannot be broken down anymore. 109 is, you divide that by x. When you break it into 2 parts, 2 doesn't go into it evenly, 3 doesn't go into it evenly, 4 clearly wouldn't go into it, any even number wouldn't. That's going to be our prime number that doesn't break down. So those are the 2 lengths. So EW is going to equal that, and so will ES. WT will equal that, and so will ST. Okay, our last 2 examples. Here we have a kite because we have 2 sets of consecutive sides congruent. We know that in between the 2 sides that aren't the same will be the angle that is the same. So that's 125. We know that 13y plus 125 and 9y plus 125. That has to equal the sum. This has 4 sides to it, so a sum of a quadrilateral is always 360. So 13 and 9 is 24y plus 225, 250 actually. We'll subtract the 250. So this comes out to be 110. And when we divide, this isn't 24, my bad. This is 22. So 13 and 9, 22. When we divide by 22, 20 times 5 is 100, and 5 times 2 is 10. So 5 times 22 is 110. Alright, for this one, take a few moments, look at this one, try to come up with a plan. Geometry, the math's not really difficult, but the plans can be difficult. You don't know what to do. Once I tell you what to do, yeah, it's real simple. You add numbers together, you divide, you multiply, you solve for the variable. But how do you set it up? So go ahead and look at this one. Alright, so here we know that we have one side and one side, two sides and two tickers and two tickers. So this is a kite. So these angles are supposed to be congruent to each other. So we'll take the 3x plus 5 to equal the 4x minus 30. So that figures out the value of x, and when we plug the x back in, we're going to get 3 times 35 plus the 5. This is 105 plus the 5. That makes 110 degrees. So this is 110. That would make this 110. Okay, so you've come up with that one. How do we figure out what this y value is going to be? Well, we know that y, the diagonal, is bisecting this. So this side is y also. Okay, alternate interior angles are not congruent. The lines are not parallel in any kite. But we do have y plus 2y minus 20 to equal 110. And then when we collect our like terms, we get our 3y plus 90 minus the 90. Oh, I'm sorry, this is 100. Subtract, let's see, these two make 90. This is still 180. Subtract the 90 to get 90 and divide. There we solve for x and the y. Again, the math itself is pretty simple, but it's deciding what to do. You need to know the rules and the properties of a kite. And in this case, the diagonal is going to bisect this angle and make it the same on both sides.